On July 2, 2025, NASA told the world that interstellar comet 3I Atlas poses zero threat to Earth. Safe distance, no danger, case closed. But 3 weeks later, they activated planetary defense protocols for the first time in history, targeting an object they claim is harmless. So what aren't they telling us? Something strangely strange is happening right now in our solar system. An object from another star system is passing through, and the response from space agencies worldwide has been completely unprecedented. Government shutdowns blocking critical data releases. Mars orbiters capturing images that still haven't been shown to the public. International defense networks quietly tracking an object that supposedly isn't a threat. By the end of this video, you're going to understand why 3I Atlas represents the most terrifying vulnerability in humanity's cosmic defense systems, and why this safe flyby might be a dress rehearsal for our extinction. Let me paint you a picture of what actually happened. July 1st, 2025. The Atlas telescope in Chile spots something moving through our solar system. Not just any object, an interstellar visitor. Only the third one ever detected. They name it 3I Atlas. The next day, NASA releases a statement, official, reassuring. The object will pass at least 1.6 astronomical units from Earth. That's roughly 150 million miles. Completely safe, no threat whatsoever. Everyone can relax. But here's where things get weird. Within weeks of that announcement, the International Asteroid Warning Network launches the most intensive observation campaign in their entire history. They're coordinating dozens of telescopes across the planet, running from November 27, 2025 to January 27, 2026, all focused on this one object. Now think about that for a second. IAWN was created specifically to track dangerous near-Earth objects, asteroids that might actually hit us. But this is the first time they've ever systematically targeted an interstellar visitor, an object that NASA just told us is completely harmless. Why would you need a planetary defense network tracking something that poses no danger? It gets stranger. During the government shutdown that started October 1st, NASA's Mars Reconnaissance Orbiter captured critical images of 3I Atlas during its closest approach to Mars. The object passed just 28 million kilometers from the red planet on October 3rd. These images could reveal unprecedented details about an interstellar visitor. But because of the shutdown, NASA's communications department was furloughed. Those images still haven't been released to the public. What did those images show? Why the silence? And here's the kicker. On October 29th, when 3I Atlas reached its closest point to the Sun, it passed directly behind the Sun from Earth's perspective, solar conjunction. For several weeks, the most scientifically valuable observation period for this object, it was completely hidden from every telescope on Earth. The one time we needed to see it most, we couldn't. Some scientists have pointed out this timing is suspiciously convenient. If you wanted to perform maneuvers near the Sun while staying hidden, solar conjunction would be the perfect moment. But that's getting ahead of ourselves. The real question is simpler and more disturbing. If 3I Atlas truly isn't dangerous, why has it triggered the biggest planetary defense response in human history?
Part 1. The detection failure. To understand why everyone's freaking out, you need to know when we actually found this thing. July 1st, 2025. That's the discovery date. But pre-discovery observations later showed 3I Atlas had been visible in our sky since June 14th, 2.5 weeks earlier. Why didn't we see it? Because it was passing in front of the galactic center, that dense region of stars in the middle of our galaxy. The comet basically blended into the background. Our detection systems completely missed it. Now here's the terrifying part. 3I Atlas was moving at 58 kilometers per second. That's 130,000 miles per hour. Faster than basically any natural object we regularly see in our solar system. By the time we spotted it, the object had already entered the inner solar system. A study released in July 2025 ran the numbers on what it would take to actually intercept 3I Atlas, to send a spacecraft to reach it. The results were brutal. Launching from Earth after the discovery date was impossible. Not difficult, impossible. Even launching from Mars would have required about 5 kilometers per second of delta V and only would have worked between July and September. Let me translate what that means. If 3I Atlas had been on a collision course with Earth instead of a safe flyby, we would have been completely powerless to stop it. Zero options. We would have detected the object heading toward us and had absolutely no way to deflect it or destroy it. Our entire planetary defense strategy is built on early detection. NASA's own 2023 Planetary Defense Strategy document says it clearly. Early detection provides the greatest leverage to prevent loss of life. You need years or decades of warning to mount an effective response. 3I Atlas gave us 3 months from discovery to closest approach to Mars. 3 months! That's not years or decades. That's barely enough time to plan a mission, let alone build and launch one. And this exposes the fundamental problem. All our detection systems are optimized for asteroids and comets that orbit within our solar system. Objects moving on predictable paths that we can track years in advance. But interstellar visitors don't follow those rules. They come from random directions at hyperbolic velocities. By the time we see them, it's already too late. Think about that. We have this entire infrastructure designed to protect Earth from cosmic impacts. Telescopes scanning the sky, computer models predicting orbits, mission concepts for deflecting dangerous asteroids. But an interstellar object can just zip through our solar system faster than we can respond, and there's nothing we can do about it. The detection gap isn't a minor flaw in the system. It's a catastrophic failure point, and 3I Atlas just proved it exists. Part 2, the speed problem. Okay, so we found it too late, but what if we had found it earlier? Could we actually do anything about an object moving that fast? This is where things get really depressing. In September 2022, NASA successfully completed the DART mission, Double Asteroid Redirection Test. They slammed a spacecraft into an asteroid moonlet called Dimorphos at 14,000 miles per hour. The impact changed the asteroid's orbital period by 33 minutes. Huge success. Proof that kinetic impactors can deflect asteroids. Planetary defense works, right? We can protect ourselves. Not quite. DART had years of preparation, detailed knowledge of the target, and most importantly, it was dealing with an asteroid moving at normal solar system velocities. Slow and steady, predictable. 3I Atlas is moving at 58 kilometers per second relative to the Sun, potentially much faster relative to any intercepting spacecraft we'd send. At those speeds, the physics completely changes. Standard kinetic impactor calculations break down. Here's why. When you hit an asteroid at normal speeds, you transfer momentum, push it slightly off course. The impact also ejects material from the surface, which provides additional thrust through recoil. That's called the momentum enhancement factor. For DART, that factor was somewhere between 2.2 and 4.9, really good. But at interstellar speeds, hypervelocity impacts produce effects we can't accurately predict. The energy of the collision is so high that you might not deflect the object, you might shatter it, fragment it into multiple pieces, each piece still carrying most of that original velocity. Now, instead of one dangerous object, you have dozens, maybe hundreds. And here's something that came out of the DART mission that nobody expected. The impact ejected 104 boulders at speeds up to 116 miles per hour. Those boulders achieved 3 times the momentum of the spacecraft that created them. The lead scientist warned that these secondary effects almost doubled the total momentum change. For a normal asteroid, that's great, more deflection. But for a high-speed interstellar object, those uncontrolled fragments could make the situation catastrophically worse. There's another problem. To intercept something moving at 58 kilometers per second, your spacecraft needs to match that velocity, or at least get close. That requires propulsion systems we don't currently have. The fastest spacecraft humanity has ever built was the Parker Solar Probe, which reached about 163 kilometers per second using gravity assists from the Sun. But that's in a very specific trajectory. We can't just point that speed wherever we want. Any deflection mission requires 3 things: time to plan and build, propulsion to reach the target, and accurate predictions of how the target will respond. For 3I Atlas, we had none of those. Not enough time, not enough propulsion capability, and the object's behavior was so unusual that predictions would have been guesswork at best. So even if we detected 3I Atlas months earlier, we still couldn't have done anything about it. The technology simply doesn't exist. We're not even close. And that's the second catastrophic failure point. Detection is step 1. Interception is step 2. We're failing at both.
Part 5. The Hidden Perihelion. So, we've got an object we detected too late, can't reach, don't understand, and can't predict. What could possibly make this worse? How about the fact that it disappeared at the most critical moment? On October 29, 2025, 3I Atlas reached perihelion. That's the closest approach to the Sun. This is when comets are most active. Maximum solar heating, maximum outgassing, maximum scientific value. If you want to understand what an object is made of and how it behaves, perihelion is the time to watch it. But 3I Atlas reached perihelion during solar conjunction. It passed directly behind the Sun as viewed from Earth. For several weeks surrounding perihelion, the object was completely hidden from every Earth-based telescope. The one time we needed to observe it most, we physically couldn't. And remember that government shutdown that started October 1st? NASA's communications department was furloughed. The agency couldn't process or release observational data. Mars orbiters captured images during the October 3rd flyby when the object passed just 28 million kilometers from Mars. But those critical images remain unreleased. What's in those images? We don't know. When will we see them? Nobody's saying. Avi Loeb made a controversial observation about the timing. If 3I Atlas were a spacecraft rather than a natural comet, solar conjunction at perihelion would be the optimal time to perform an Oberth maneuver. That's using the Sun's gravity to accelerate or decelerate while conveniently hidden from Earth's view. Basic astronautics. Is that what happened? Almost certainly not. But the operational reality is the same either way.
The most critical observation period occurred when Earth-based monitoring was physically impossible due to solar conjunction and operationally crippled by government dysfunction. We're missing crucial data about how interstellar objects behave at perihelion, data that would be essential for planning future deflection missions. And we're missing it because of bad timing and bureaucratic failure. This isn't just unlucky. This exposes how fragile our observation capabilities are. A natural occurrence like solar conjunction combines with human dysfunction like a government shutdown, and suddenly we're blind. Imagine if this had been a real threat, an object on a collision course, and we couldn't observe it at the most critical moment because Congress couldn't pass a budget. That's not a planetary defense system. That's a disaster waiting to happen. The IAWN campaign and what it really means. On October 21, 2025, the International Asteroid Warning Network made an announcement. They were launching an unprecedented observation campaign targeting 3I Atlas, running from November 27, 2025 to January 27, 2026. First time IAWN has ever systematically focused on an interstellar object. The stated goal? Improve techniques for accurate comet astrometry. Develop better methods for precisely measuring position and trajectory. Sounds reasonable, scientific, routine. But here's what's actually happening. This is a training exercise, a live drill using a real interstellar visitor to pressure test systems that have only been exercised theoretically. Think about it. IAWN was created specifically to detect, monitor, and characterize potentially hazardous near-Earth objects. It's a United Nations-backed international collaboration. Its entire purpose is planetary defense. And now they're using it to track an object that poses no threat. They're rehearsing, practicing, because they know what 3I Atlas represents. Not a danger in itself, but a proof of concept for a threat category humanity cannot currently address. Fast-moving interstellar objects detected too late for effective response. Every weakness in the planetary defense infrastructure has been exposed. Detection gaps, inadequate propulsion, compositional uncertainty, unpredictable behavior, observation failures, coordination breakdowns during government shutdowns. Military analysts have taken particular interest. Defense networks designed to track satellites and missiles operate on completely different timescales than what 3I Atlas demanded. An analysis examining why the object has militaries on alert noted that ultra-fast, unpredictable objects could cause temporary detection gaps, revealing vulnerabilities in global surveillance networks. The piece concluded that future systems will need to evolve to spot and respond to objects entering near-Earth space at these speeds. But those future systems don't exist yet. We're talking about capabilities that are largely theoretical. NASA's 2023 Planetary Defense Strategy explicitly calls for rapid response capabilities, evaluation of reconnaissance via spacecraft flyby or rendezvous, rapid response deflection and disruption missions. But as of 2025, these remain concepts. Current spacecraft require several weeks of notification for integration and launch. Even hypervelocity flyby missions face instrument limitations. The National Academy's Decado survey identified as highest priority a rapid response flyby reconnaissance mission to a challenging near-Earth object. This recommendation emerged precisely because short warning time threats like 3I Atlas expose our current inability to respond effectively. Two architectures have been proposed: ground storage with launch on detection, or in-space storage in parking orbit. Each has major drawbacks. Ground storage requires dedicated rapid launch capability that doesn't exist. In-space storage requires spacecraft that can operate for extended standby periods while remaining capable of swift deployment. And even then, you have less energy available to reach the target. The IAWN campaign isn't about this specific comet. It's about using this rare opportunity to develop capabilities, test coordination mechanisms, and identify technological gaps that must be addressed before we face a true emergency. Because next time, we might not get lucky. Next time, the object might not pass safely at 1.6 astronomical units. Next time, it might be aimed right at us. And if that happens tomorrow, we have zero ability to stop it.
So, let me answer the question from the beginning. If 3I Atlas isn't dangerous, why is NASA bracing for conflict? Because 3I Atlas isn't dangerous in terms of impact, but it's extraordinarily dangerous in terms of what it reveals. Every single planetary defense system we've designed assumes targets that behave predictably, move relatively slowly, and can be observed and characterized over extended periods. 3I Atlas violated all those assumptions. It showed up late, moving impossibly fast, with unprecedented composition and unpredictable behavior. It disappeared during the most critical observation period. It exposed detection gaps, propulsion limitations, coordination failures, and technological inadequacies. The intensive response isn't about the specific object passing through our solar system in 2025. It's about the next one, the one that might arrive on a collision trajectory. The one that might be detected even later. The one that might move even faster or behave even more unpredictably. The one that could transform from astronomical curiosity to civilization-ending threat in the weeks or months between discovery and impact. Too quickly for humanity's defense infrastructure to respond effectively. NASA scientist Tom Statler said 3I Atlas looks like a comet, does comet things, and strongly resembles comets we know. He's right, but that assessment misses the deeper point. What matters isn't whether this particular object is natural. It is. What matters is that this natural comet revealed catastrophic vulnerabilities in every system designed to protect Earth. The conflict NASA is bracing for isn't with 3I Atlas itself. It's with the next interstellar visitor, the one we might not see coming until it's already too late, the one we can't reach, don't understand, and can't predict, the one that arrives without warning and ends everything before we even realize we're in danger. 3I Atlas is a warning shot from the universe, a preview of a threat category that could end human civilization. And right now, we have no defense against it. That's why they're bracing for conflict. Not because of what this object is, but because of what it represents. A problem we can't solve, a threat we can't stop, an extinction event we can see coming but can do nothing about. And the terrifying truth is that it could happen any time, tomorrow, next year, next decade. An interstellar visitor arriving too fast from the wrong direction, and humanity powerless to do anything but watch. If this kept you interesting, do subscribe.